Okay, so let's do Math 86, Arithmetic and Pre-Algebra Unit 0, Lesson 1. We're going to do the first 2 pages, and I'm going to do the decimals on another video. So the first page is about mixed numbers and a number line, and so right here we're doing, let's see, Unit 0, Lesson 1 warm-up. So let's think about some different ways that you can write some numbers. So this is my number line, starts with 0, and going this way are all positive numbers. So these are all positive numbers, okay? Different ways you can write things. This is a decimal. I've got a couple of decimals here and a couple of mixed numbers. So there's a decimal that's 0.5. Well, let's see. How about if we number our number line first? There we go. Some whole numbers. And 0.5 would be what? About halfway. So that's the decimal. 0.5 be halfway to 1. 1.6. Let's see. There's 1 and 2. 1.5 would be halfway. 1.6 would be, I don't know, about there. 2 3/4 is between 2 and 3. Half would be about there. 3/4 would be about there. 3 obviously here. 4 1/4. Well, if that's about 4 1/2, 4 1/4 is about here. And this represents 5 and a repeating 3. This little dash means a repeating 3. So 5 would be about there as a decimal. So 5 3 repeating would be about there. Repeating as in 0.3333 goes on forever. So the short way to write that is a 3 with a dash over top. So that's 5 repeating. So these are all different forms of positive numbers, and that's approximately where they would be on a number line. So we just want to make sure we understand how to represent these numbers in these different forms. So let's practice a little bit of this. We have, let's see, mixed numbers. How many of you remember how to convert a mixed number, 2 3/4, into an improper fraction? So let's see. Mixed numbers are made out of a whole number part and a fractional part. Okay, so to put them all together into an improper fraction, it's 2 times 4 plus 3. 2 times 4, the whole number part times the denominator, okay, plus the numerator, all over the 4. So keep the denominator on the bottom. And then order of operations, say you do 2 times 4 is 8 plus 3 over 4. That gives you 11 over 4. That seems reasonable. What would 3, if you have 3 4s, you have 12. So 2 3/4, you don't have 3 4s, you have a little less. So 11 over 4 seems reasonable. You always want to kind of check and make sure if you're using your calculator a lot that you come up with a reasonable answer at the end. I'm going to go kind of down this way. Let's try C next and just kind of stick with the mixed numbers into improper fractions. So the rule was you take the denominator, it's going to stay the denominator, okay? And then it's the whole number part times the denominator, 4 times 4, plus the remainder is 1 in the fraction. Order of operations, say you do 4 times 4, and we'll do lots more orders of operations. You're just going to hear me say it a lot. It's a big part of this class, so I'm just going to refer to it as often as possible. If you have 4 times 4 plus 1, make sure you're doing the 4 times 4 first, plus 1, and that's going to give you 17 4s. Okay? You can break this up. You can just do it off to the side. 4 times 4 is 16. Add the 1, and you get the 17. You don't have to do the steps that I do as long as that's your final answer. Okay? Let's see. Think about it. Is that reasonable? 4 times 4 is 16. So if you have 17 4s, you have 1 more than 16 4s. So that seems reasonable. So let's do, there's one more down here. If you don't mind, I'm kind of going that way, and then we'll come back to these other ones. So I don't know why these are all 4s, but so it would be 11 times 4 plus 1 all over 4. So 4 times 11 is 44 plus 1, 45 over 4. Okay, that's how we take a mixed number and turn it into an improper fraction. An improper fraction is when the number in the numerator is larger than the number in the denominator. Okay, you'll find that in high school, a lot of things you were told to change into a mixed number at the end. Do not leave them at improper fractions. When we're working our way towards algebra, and in algebra, we mostly use the improper fraction. So we want to make sure we understand how to make them, okay? So, but, so over here we're given an improper fraction of 17 over 6. How do we turn that back into a mixed number? Should we somebody's not going to tell you they have 17/6 of something. They're going to say they have some sort of mixed number of something. So to refer back to the mixed number, realize that this is actually division right here, you could actually do 6 into 17. You can also put it in your calculator. 17 divided by 6 will give you a decimal number, but that won't give you the mixed number that we want. There's no decimal in these mixed numbers. So make sure you understand how to come up with a mixed number. So I think the easiest way that you're taught before maybe was 6 into 17 goes twice, because 6 times 2 is 12 with a remainder of 5. Now, a lot of people can do this step, but they're a little confused how to get whether to put the 6, the 2, and the 5, where to put them, okay? Well, if you can think about it, 17 has 2 6s in it. That's where the 12's coming from, so the whole number is the 2 part, okay? And then the fractional part is the remainder of the 5. And then you always keep the denominator that you had. So 17/6 turns into 2 and 5/6, right? Think about it. 3 times 6 is 18, so you almost have 3. So you have less than 3, but more than 2. You have 2 and 5/6, okay? So all of them can be done that way. This is 23 divided by 5. So 5 into 23, let's see, goes 4 is 20 with 3 left over. So that means 4 5s are in a 23 with 3 left over. Okay, and you can also check by kind of going back to the mixed number. So this would be 24 times 5 plus 3, 23, right? So you can always check your final answer there. So let's see, 7 into 22, 3 times, it's helpful if you know your times tables. If you don't, you can put it in your calculator, do 22 divided by 7. Your calculator will come up with 3 in a decimal, so you can always use that whole number 3 and then try to figure out the rest. Well, if the whole number is 3, put in your calculator 3 times 7 is 21, okay? And that's 1 away from 22. So we have 1 remaining, and don't forget the denominator goes back on the bottom, okay? So if you're trying to decide which is larger, there's a couple ways to go. You can put this in your calculator, 67 divided by 8. 67 divided by 8 in your calculator. You're going to get 8.375. Okay? You put 19 divided by 2 in your calculator, you're going to get 9.5. And the instruction says, tell me if it's, which symbol goes in the middle. Well, which number is bigger? This number is bigger over here, so that's a greater than symbol like that. This is greater than that. Excuse me, but really what this is called is a less than. Sorry, I just confused you right there. Let me write it down and then I'll... Okay, this number is greater than that number, so the opening goes towards the greater. Some people remember as this is like the Pac-Man or a alligator or something like that. It opens its mouth and faces what it's afraid of, which is the bigger one. I don't know how you want to... I remember it as an alligator, but Sorry if you don't need any of that. That is considered a less than symbol with the opening going towards the greater than, okay? If you wanted to change these backs to mixed numbers, this would be 2 into 19. So that would be what? A 9 there, which would be 18, and a 1. So this would be 9.5. And over here, this would be 67 divided by, sorry for the poor handwriting here. This would be what? 8. Excuse me. And that would be 3, so this would be 8 and 3/8 on this side. So clearly 9.5 are larger than 8 and 3/8. So this is the correct symbol for this spot. Okay. This one I'm giving a mixed number for, and then this one I'm giving an improper fraction. Notice that both the denominators are 8. So what I need to do is convert this to an improper fraction. So this would be 15 times 8 plus 3. I did that in my calculator. That comes out to 123 over 8. 119 over 8. Clearly this one is larger. So the opening faces this way, and this is a greater than symbol. You use greater than and less than symbols in statistics, which most of you are going towards. So we start sprinkling them in so you start understanding them and get used to seeing them. Okay, so let's do the next page. And remember, you can rewatch this video. I know I go fast, so that's why it's on video, so you can play it again if you need to. Okay. So let's go to the next page. We were putting numbers on a number line, and that was getting us ready to talk about what we really needed to cover, which was integers on a number line. All right, we just put some whole numbers on a number line. We put whole numbers on a number line. Integers are a little more than whole numbers, and we'll get to that in a second. Then we're going to try to find absolute values and opposites of these numbers. And then we're going to talk about decimals. Decimals to fractions, fractions back to decimals, and be able to round decimals. So we got a lot more to do. So the rest of this video, I'm going to concentrate on the integers on a number line, the absolute value, and the opposite. I'll do another video on the decimals. Okay. So, excuse me, 5.1 in the arithmetic book talks about locating integers on a number line. A real number line consists of rational and irrational numbers. This is a real number line here. Notice we have a little more space to the left of that 0 now. So the positive numbers are on this side of the 0. The negative numbers are on that side of the 0. And I'm just going to write them in here. When I put these numbers in here, like I did before, these are whole numbers. Oops. These are whole numbers, okay? And then you kind of go this way. When you go into the negative numbers, you're writing, some people call them negative whole numbers, not quite the right definition, but you get what I mean. When you number a number line, these are called integers, okay? When you get into the natural numbers, you know, they didn't used to have a 0. They didn't really think they needed something. They didn't know they needed a kind of a word for nothing, because I don't know whether counting goats or whatever. I have 1, 2, 3, 4 goats. You know, they don't walk around going, I don't have any goats kind of thing, but then they figured out they needed them. I made that up. So they needed a 0, so that it wasn't until later that they decided they needed some negative numbers. And let's see, before you ask me for a real life example of that is kind of when you owe money and then you owe more money. Let's say you're overdrawn on your checking account, and then you write another check. That's another minus, so you're kind of adding minuses. You need negatives in real life, whether you know it or not. So we're going to make sure you understand them. So something else we need to talk about is absolute value and opposites of a number. That was kind of in my way there, sorry. Absolute value and opposite of a number. Notice, I'm going to read right here. Notice the integers come in pairs of positive and negative numbers. each number is the opposite of the other number in the pair. The number and its opposite are the same distance from 0, so they have the same absolute values. Oh, let's talk about this again. So here's a positive 1. Here's a negative 1. These are pairs of opposite numbers. Okay, negative 1 is the opposite of 1. 1 is the opposite of a negative 1. They are the same distance from the 0. 1 is 1 unit from 0. Negative 1 is 1 unit from 0. They are the same distance from 0. Therefore, they have the same absolute value. Absolute values are always positive because they represent a distance. Okay? Or 0 itself isn't a distance from itself. So that was a little weird. But to write the absolute value of a number, use 2 short vertical lines on either side of the number. So right here, this says this is how you read this right here, is the absolute value of negative 3. The absolute value of negative 3 is 3. Negative 3, let me put it back up here. Negative 3 is 1, 2, 3 units from 0. Positive 3, its opposite, is 1, 2, 3 units from 0. So the absolute value of a negative 3 equals 3. The absolute value of positive 3 also equals 3 because they're 3 units from 0. Okay? Both negative 3 and 3 are opposites of each other. So if you're talking about integer pairs, the opposite of a positive 1 is a negative 1. The opposite of a negative 3 is a positive 3. The opposite of a negative 5 is a... the opposite of a 5 is a negative 5. The opposite of a negative 7 is a 7. The absolute value of a negative 5 is 5. The absolute value of a positive 5 is 5. The absolute value of negative 9 is 9, 6, and 8. Okay? All right, so I'm going to make another video for the other pages for the decimals.